Hi, everyone, and welcome to the MLOps podcast. I am your host, Dean, and today I have with me Michał Oleszak. Michał is an ML engineering manager at Solera, where he leads a team of data scientists and ML engineers. And they're building some really cool ML solutions in the automotive space, specifically in the claim industry, such as recognizing damages from images and more. He is also an instructor for data science in Data Camp, where he teaches deep learning with PyTorch and Bayesian models. Michał, thank you for taking the time today.
Thanks for having me.
Awesome. Let's dive into it. Tell me a bit about production for machine learning at Solera. How does it look like?
Right. So Solera as a company offers a broad range of different solutions for the automotive sector. But what my team in particular is working on is, as you mentioned, machine learning based solution for the automotive claim, processing of claims. So what we might have in production is a range of models performing different tasks. Mm-hmm. Given a collision, you as a driver would take a couple of pictures of your vehicle. These would then be sent to our backend where they are fed into the models, which tell you whether the car is a total loss or not, to know if there's any point in trying to repair it, even estimating the cost of this repair, because it's obvious that this car is unrepairable. Then it should be sent to a salvage yard immediately, just to save time and money. We would try to recognize which parts of the car are damaged and predict what sort of operations have to be conducted in order to repair these parts, which leads us to an estimate of the cost, how much you would pay either as a customer or as an insurer, how much it would cost you to get the vehicle repaired. Finally, we also have a model that's trying to estimate the fairness of a repair offer. If you're an insurer, you receive an offer of repair from a body shop, you need to know whether that's something you should agree to pay, or whether that's not really fair, as in it should have been cheaper, in which case you would probably look for a better offer. So all of those models have to work together to process the information that we receive.
So you're basically providing a service both for the insurance and the insurers, right? If I understand correctly.
Right. So most of our customers are insurers, insurance companies. But the breadth of products we offer is quite large. So I might not be aware of some solutions that are exist directly to end users.
Okay, I see what you mean. For the use case that you described earlier, like I think that's interesting because you're I like that you're describing this from a use case perspective first, and then an ML model perspective. Sometimes people start, with the technicalities of what they're deploying. But what you're describing sounds like a multi-stage, like a pretty complicated multi-stage pipeline, and which I can imagine the first part of which is sort of maybe a more classical computer vision model, but then you tie that into things that are more maybe complicated classifiers that need to map to very specific definitions of damage and repairs and things like that. If you can share, I'm curious to hear like how that connector looks like transitioning between the image parts to maybe the more structured part of discovering what repairs need to take place.
Yeah, so you're right, 100%. So there is much more to this than just training a model and exposing it through an API, getting it into production, and just letting it receive images, produce predictions. There's so much more. Because there are different models operating simultaneously, and then the outputs of these models have to be reconciled and put together somehow to produce the binary results that we serve to our consumers of our APIs. And yeah, there are elements to it that are specific to how we internally recognize different parts of the vehicle and what kinds of operations can be applied to these parts, what kind of things make sense to do. Like you would be able to paint the door, but you probably wouldn't paint the tire, right? So all of those things have to be taken into account, and the outputs of all of the models have to be combined in a smart way.
Very nice. And are the more structured parts in this process also based on deep learning models, or do you combine deep learning and non-deep learning models in your pipelines?
there is deep learning involved. There's some custom logic as well, just rule-based elements in the pipeline. All of those.
Awesome. And then for all of this thing, like how do you deploy it to production? How does the deployment process look like?
Right. So I won't talk specifically about the details of how we do it at Solera, but in general, considering my prior experiences, I think the production is not something that happens late in the development cycle. It's not like you work on a model and then you test it and then you deploy it and then you serve it in production. To me, production actually starts quite early, as soon as you start writing code, basically. And this is because when you already have a system in place that's responsible for delivering code, you have a repository with a CI/CD in place, with a unit tests or other test suites, and you are contributing a new component to that code base, you need to already be thinking about how your model would work in production, how it would integrate with the other parts, how your code would fit into the code base. One approach to delivering code that I'm a fan of is a monorepo, so a situation in which all of your code or a large portion of your code sits in the same Git repository, so that you can reuse some portions of the code that are applicable to different components that you build, so that you don't you stay dry, you don't repeat yourself. It also offers you a single CI/CD pipeline, which means that there's no hidden deployment knowledge that it's scattered around different people that were responsible for building and deploying different things, but rather you have just one centralized way of delivering changes and deploying changes. And obviously, all the things that, if you think about all the activities that machine learning engineers would do other than writing code in the repository, like running tests or running linters, type checkers, or building, Python wheels, Docker containers. All of those things are much easier if you have a single code base and an associated build system that works with this code base and can handle all of this stuff automatically for you.
Okay.
And
go ahead.
Yeah, just wanted to wrap up with this. It was quite a lengthy introduction, but what I was aiming for is to say that once you have these the system of code delivery in place, then you don't really think about deployment anymore that much, because it has been thought of before. And once you have a new element to your system that you want to deploy, you just kind of include it in the already existing infrastructure, and it gets deployed automatically.
Okay, so for the monorepo architecture, like I agree with the benefits that you mentioned. One of the challenges could be that there's like different logical components that look differently in the same repository. I'm curious if you solve that by maybe defining, like what we've seen in some places, that there's an interface defined for a model, and that is supposed to be generic enough to support any type of model, and then you expect the data scientist to sort of comply with this interface, sort of like a contract. Or if you have thought of other solutions for this problem, like how do you deal with that in the monorepo example?
Yeah, so these templates or contracts are a great way to making sure that all models or all components of your system work in the similar fashion or follow the same API. It's also a matter of the developers themselves realizing how much easier it is to write code and to contribute new changes in this setting. And then they will be willing to use the existing things rather than develop something from scratch again and again.
Yeah, I think that there's a lot to say for convenience in adopting new workflows. Like when you try to introduce a new workflow, whether it's monorepo or just a new way of deploying a model or something like that, going the extra step of making that very convenient for the people that are going to interface with that process regularly, which ideally I think is an ML, there's a title thing here, but if you're responsible for building out the deployments, the deployment pipeline rather, and not doing the deployment themselves, you try to sort of make it very accessible to the people that you want to be able to deploy the model. And I think that that's a very important process to support in this context as well. So I guess one question I have is, what have you found to be the main challenges with working in a monorepo architecture, and how have you solved them, or how do you think about solving them?
Yeah, that is a good question. So I think one of the biggest challenges is when you are starting, you're typically not starting from scratch. You don't have an empty sheet and then decide like let's start with the monorepo. You have the existing situation of different repositories, often using different different approaches to the things, different code styles and so on, and you have to successively bind them together, put them together into this one monorepo. And obviously, this is never something that has a high priority, because you have work to do, right? You have the deadlines to meet. You have tasks that are far more important. So this is one of those things that people tend to agree on. Yes, we should do this. Yes, this part of code should be in the monorepo. Let's put it there. I have a task in the backlog, right? Some of those things take time to actually get done.
So do you have tips for people that are facing this on how to either get this into the priority list or make it efficient so that it's easy to get done?
Yeah, one trick that could work, although it's also additional work, but if you're talking about large code bases, it actually could pay off, is to try, if you're using some sort of a build system in the monorepo, and just as a side note, so the build system is kind of a piece of software that would take care of all those non-code writing related activities I mentioned, building packages, images, running test suites for you, and so on, and managing dependencies. If you're using this in your monorepo, you could try to use the same tool in the same way in this other code base that you intend to merge with the monorepo in the end. And if you successively step by step introduce this build system for this self-contained code base, then at some point you reach such a high level of coverage in terms of this build system that it's easy to just copy paste that code to the monorepo.
Okay, fair enough. And with respect to the models themselves, so it does sound like you're combining some, I don't know if to say it like off the shelf, but you're taking some standard functionality, like probably object detection and things like that within images, and combining with a lot of custom logic and probably maybe custom models. I'm curious, like within this complex system, how do you evaluate model versions or pipeline versions and make sure that you're actually getting better?
Yeah, this is a great question, and it's never easy to evaluate machine learning models, and it is a challenge for us as well. As you mentioned, for all of these different models that we have, there's always metrics, machine learning performance metrics that are specific to the task you're solving, right? So if you have a classifier, you would look at precision, recall, F1 square, and so on. If you have a object detection model, you can look at the IOU or whatever metric you like. But in the end, the final output of the entire system is so much more than the individual output of the models.
Yeah.
So in order to be able to evaluate this, what needs to be done, and what we are doing is to set up a dedicated scoring pipeline that we run against. And that's still not enough, because what you get as the output is a range of metrics that you're interested in, not machine learning metrics, but more of some of them business related KPIs, some of them some sort of model accuracy metrics. But then you're facing this challenge. What happens if some of them go up, some of them go down, and you're comparing the models. Let's say you have a pipeline that you have in production, you have pipeline that you came up with, and you're hoping it to be better. You run the scoring, and you have a couple of metrics. Some of them are improving, some of them are getting worse, and it is not easy to first know for yourself as an engineer which of these models is good. But even if you reach a conclusion, and I'll talk about how it could be done in a second, but even if you know which models is best, then you have to also make sure that the consumers of your models or the business side will also accept this solution as better.
Yeah.
But coming back to the situation in which you're facing a couple of different metrics, what I typically like to do, and I think unless I'm mistaken, I think this idea was propagated by Andrew Ng, the founder of Coursera. He came up with this idea of satisficing versus maximizing metrics. So when you're dealing with a couple of metrics, you select one that is the most important to you, that you want to be as high as possible or as low as possible, depending on what you're measuring, but you want it to be, optimal. And all the other remaining metrics have to meet some thresholds that you select for them. So then, then you pick the solution that meets all the thresholds, and among the solutions that meet all the thresholds, you pick the one that has the best value of this optimizing metrics.
Sure. I think that really, I agree with that. And I think one of the really simple examples that I've heard in the past is like, if you're building a model to detect disease, then you are sort of deciding that you want to maximize the amount of correct detections while making sure that there are, zero missed, zero false negatives, basically, right? Because you don't want to miss anyone who's sick. Given that you're not missing anyone who's sick, what's the maximum amount of true positive that you can get? So this is like a simplified case because it's just 2 metrics, but you can imagine that if you have, 7, 8, 10 metrics, then you can do the same thing with all of them. The interesting point that you made also that I wanted to ask about is involving the business people or maybe the less technical people in the decision process. Obviously, like we can say the obvious stuff, like you have to have good communication with the business stakeholders, which is true. But I'm curious, how knowledgeable do you think they need to be in like the ML terms and things like that? Or do you just talk to them in a high level, try to understand what they need in their terms, and then break your head against the wall until you figure out how to translate that into numbers for the model?
Yeah, that's another good question. But if that's okay, I want to go back quickly to one thing you just said, which also actually relates to the conversations with the business side of things. You mentioned this example with medical diagnosis where different types of errors have different costs, right? So if you miss a disease, that's potentially a very bad outcome. But if you misdiagnose someone as sick when they're in fact healthy, that's of a cost, right? You maybe pay for some additional screening diagnosis, but it's nothing terrible, right? The same applies to many other cases where you have a model or a machine learning-based solution that can give you different outcomes and then can make different types of errors, right? Either you over-predict or under-predict something. If you have a classifier, either you misclassify something as one thing or as something else. And all of these different errors do have different kind of costs that the business incurs, or either in terms of money or time or missed savings, whatever it be. And it's great if you have a possibility, or if it's if the business people are able to tell you what these different costs are. Obviously, this is not as simple. It's not like you can assign a dollar value to every type of error your model can make. As the closer you get to this point, the better. This, first of all, makes sure that your models are chosen with the right criteria in mind and are solving the right thing. And then it also builds trust between the developers and the business, because they can see that you care about what they care about, and that your solution is indeed impacting the metrics of the KPIs that they're looking at. And that, I think, partly is a segue to your question, which was, if you would say it again.
Yeah, just like, it's pretty much an answer to the second question, which is just like how deep into the technical know-how do the business stakeholders need to be in order to have this like healthy conversation, versus not just telling you at a high level like what they want and then you worrying about the translation to ML metrics.
That's a good question, but I think, at least from my perspective or from my experience, there's no role to that. So in the past, I used to work at a software house where we would do machine learning projects for different customers, and I got the opportunity to interact with many different people from many different sorts of companies. and they're all different. Sometimes you have a manager who's non-technical, who's just responsible for managing the project or the team. And even though they might miss the technical vocabulary, they might still be a great partner in those conversations. If you explain to them what it means, what you're trying to show, they might understand or be willing to understand and work with you. And on the other hand, there are technical stakeholders who would argue with you. Some people, given that they have some level of technical understanding, they would try to show it off and then prove to you that you haven't thought of something, and they would throw technical words at you. So there's no rule, I think.
Okay. Yeah, I think that at the end, when teams work well together, you sort of come to this middle ground on the spectrum between technical and non-technical. And I think you gave a really good example, which is like, in a sense, you as a data scientist need to put on a product manager hat and interview the business people as if they were your users. Like, what do you care about? Is this more painful than this? What does it mean when we fail at this thing? And then translate that. And I think over time, even if you're not trying, what's going to happen is that the business people will also gain a better understanding of what metrics mean and everything. But yeah, it starts with communication. I think it's usually easier for the data scientist to start by moving towards the business side than for the business to move towards the data science side, and then find that middle ground. But yeah, I think that's a really, really good point. What about tools? Like, what tools are you using within your machine learning project? Like, you mentioned Monorepo, so I know you're using Git, but what else do you use?
Right. So Monorepo, I mentioned the build systems as well. So the one I like particularly is Pants. There are actually two. I mean, probably there are more. There are two that I'm more familiar with and aware of. Two build systems that are well suited for Python, because most of machine learning code is still typically Python. And the two build systems that are quite applicable are Pants and the other ones, I think Bazel. Bazel is a spin-off, if you will, of like Google's internal system, which was called Blade. They always do these not acronyms, but they just switch the order of the letters. And when I was researching these build systems for my team, I looked at Ants and Bazel. They are both great. They offer pretty similar functionalities. In the end, I think I ended up choosing Pants because it's supposedly easier to start with and set up. And also it has a great community. So when I was just starting with it, I wouldn't understand some portions. I would just, ask in the community Slack, and a lot of helpful folks around there would support me. And yeah, we've been using Pants for some time now, and it's working really great. And then for other tools, well, depending on where you deploy your model, so that you're using the cloud, if you're using some on-prem machine, that would probably be different. We are currently on a cloud, and you're using the offering from the cloud provider.
Okay.
And that's mostly it in terms of the infrastructure and the CI/CD. We also make use of GitHub Actions, which is a really, really nice framework for building the CI/CD pipeline.
Fair enough. What about the data management? How do you manage your data?
I was reading until we come to the topic of data. Always an interesting part.
Yeah.
So there's one thing is storing data, which you can do it also in the tools provided by your cloud providers, be it S3 on AWS or Google Storage on GCP and so on. But actually, I think most of the tooling around data that I've played with recently is related to the data quality and making sure that the data you receive is actually adhering to the schemas or standards or quality levels that you hope it to meet. There is this great library called Great Expectations.
Sure.
Which is I think mostly designed for tabular data. At least that's what we've been using it for. It allows you to do data validation. Anytime you get a new portion of data, you can scan it automatically and verify whether it meets the expectations that you have of it, which allows you to either prepare your clean your data, your training, your test sets, but also, and that's something that I used to do in the past. You can use those data validation tools like Great Expectations to actually you can use them to build a gateway for your data at inference time. So as long as your inference time allows for it, if you have to return the response immediately, then probably slowing it down with validating the data in such an advanced way might not be a good idea. But in many cases, you can afford to pass the data inference query through a data validation tool and react to it if it's not as you expect. Because even if you throw an error, or if the best thing you can do is probably throw an informative error. But whatever you do is better than serving a model prediction that's completely off or doesn't make sense because of the input data being invalid or not familiar to the model.
Yeah, I think a lot of the solutions we see on the deployment side is that data validation happens as part of the inference process, not as a separate tool. Like Great Expectations or tools like that would be used within the data building process or data set building process as opposed to inference. But I suppose you can use that for both. Yeah, and I'm familiar that it's good for tabular data. I don't know how it works for other stuff. Do you use something to manage the unstructured data, or is that just in the bucket and that's good enough?
Yeah, so there's a lot of data in the buckets. The question is how to choose which data are good enough to use for model training, for test sets.
Yeah.
There's a large variety among the data, so you also want your training testing data sets to be representative of the data that you expect to see in production. And with image data specifically, I like to think of image data quality as two kind of independent, well, maybe not completely independent, but two separate ways of capturing quality. So there is what I typically refer to as objective quality, where you can objectively just look at the image and say it's bad, it's all black, it's blurred, it's overexposed. Or all those sorts of things compressed multiple times and showing strong JPEG artifacts or whatever.
Sure.
So that's this objective quality, and there is this other notion which I refer to as subjective quality, where the data, the image is perhaps okay objectively, but not okay for what you intend to do with it. As on the case of for example, the car damage predicting model that I mentioned, you would want your training data to show the car from outside. Many images are not really useful for the task of damage detection. They are show elements of the car that are not just not relevant for this task. So finding those and excluding them from the training data sets, that's not an easy task.
Sure.
And we're still on the way to figure out how to do it properly.
Interesting. Yeah, this is something that we thought quite a bit about. There's the part of detecting sort of an anomaly detection of what isn't relevant, and there's the other part of extracting the relevant information because it might be relevant for a certain task but not for another task, and how do you filter by those things? It's related to some of the things that we've built with our data set management tool. I think in the end, there's extracting the information is case by case, right? It depends on the task that you have. And again, there's no as you said, it's subjective. So it will differ between different tasks and different companies, of course. But then once you have the information, you can theoretically query it as if it was tabular data to create different subsets for different tasks, which I think is very relevant to the work that you're doing. So I guess one last question I have before we go into the quick fastball questions is what's the biggest challenge in your ML efforts right now, and how are you solving that?
Yeah, I think that would be data quality and detecting data quality and ensuring that what the data that you're able to curate the data for your use cases. That's exactly what we just talked about.
Nice. Okay, that's fair enough. And so you already answered like how you're thinking about dealing with that, and that's super interesting. So I guess going one step higher, you personally, what are you most excited about in the field of machine learning AI?
Yeah, so well, there are many exciting developments. I'm inclined to mention something that's not related to LLMs because I think that would be interesting and even exotic. Yeah, as I mentioned before, I used to have some experience with self-supervised learning in the images domain mostly, and there's some quite interesting work going on there. Most significantly, I think what Jan LeCun and his team at Meta are doing with these JEPA architectures, the joint embedding, Joint embedding predictive architecture, I think. So
Yeah.
these models that try to learn what they call world models. So in a typical um, self-supervised approach for computer vision, you would take the image and then you would change something with this image, maybe mask part of it or rotate it or apply some sort of augmentation, and then you could do either contrastive learning um or just predict mask prediction or some other operations to construct the labels from the training data itself, construct this pretext task, and then get the model to kind of learn the image representation. And these JEPA architectures are quite similar, but they're doing the same thing, but not on the image itself, but in the latent space. So first you have an encoder, you process the image, you get some embedding, and then you do some operation, some augmentation on this embedding, and then you try to predict back, for example, the masked portion of this embedding. And the idea behind it, as far as I can understand it, is that if you do this on the images themselves, then the model has to focus on every single pixel. So that the same computing power goes into predicting the pixels that are important and the pixels that are not. So one example that's often given is with this person standing, in the garden with the trees in the background. If the model puts a lot of effort into making sure that every single pixel in the leaves in the background is sound, that's not how humans perceive things. If you look at such a picture, you would focus on the person, not on the background. And the idea behind these JEPA architectures is that by doing this mask prediction in the embedding space, the model would actually not focus on every pixel, but rather on this concept that's supposed to be encoded in the embedding. And to me, that's quite exciting. They're regularly publishing new versions. So there was this iJEPA for images. Now, I think earlier this year we had a vJEPA for videos. And these models could be the next big thing after the LLM hype has passed.
Interesting. Yeah, I think Jan LeCun is very serious advocate of like LLMs are not the final form, and there's more to discover and develop on the way to AGI or super intelligence, depending on how you want to look at it. He has a lot of heated debates publicly, which I, as a spectator, I can appreciate. I think it's very interesting. I think in general, like works that are trying to map things like inputs to concept space are very interesting. I think there's a bunch of works from Anthropic about this as well. We're still early, as you say, so there's a lot to develop, but I agree with you that it's very interesting. So on the controversial side, aside from not focusing on LLMs, tell me something that you think is true, but that few people would agree with around ML and AI.
All right. So it might be just because because I'm biased towards my background, but I believe it is important for ML folks to actually get some understanding of statistics. And I know this is not really popular in some circles. And I know great computer science majors or graduates or software engineers who not necessarily have a strong background in statistics, and they do their work just fine. But I've also seen a couple of projects that got derailed because of someone who's really a great engineer would just overlook, or not necessarily overlook, that they would just not know where to look because of some gaps in the statistical theory background. So even things as simple as data imputation, right? If you have tabular data, you have some missing values, you need to fill them in with something. Many people would just fill them in with the mean or the median, and that's probably fine in many situations. But if you don't know what kind of artifacts it introduces to the data, you might not know why your models are not performing the way you want. And in some cases, actually, I've seen a situation in which a kind of incorrect data imputation led to a model that would fail only in specific ways. And until it got a specific type of input, it would perform well. And then when this happens, you get very poor results. And it was quite difficult to find out what was the reason for that.
Interesting. The data imputation is important, and statistics is important as well. I agree with you. Okay, so to wrap this up, any recommendations for the audience? It doesn't have to be related to data science, but feel free.
Yes, something not related to data science. I have recently finished reading a book called, what was it called? Prisoners of Geography by Tim Marshall. He's a British journalist. And in this book, he has very strong opinions, so you might not agree with what he says, but nevertheless, it's quite interesting to read. He argues that the geographical features, like rivers, mountains, seas, and then the location of their locations on the map, determine the choices that political leaders have, and then determine to a large extent different world events and world politics. It's a really interesting read. I don't know if I agree with him 100%, because on some occasions he's just arguing that this war would not happen if these mountains were a little bit shorter. But it's nevertheless a very good read, in my opinion.
Interesting. Yeah, geopolitics is I like that as well. There's a few podcasts. The main one that I'm listening to is in Hebrew, so I don't know if it's a good recommendation, but there's one that's called The Big Game in Hebrew. It talks about geopolitics, and one of the first parts is he talks exactly about that topic. He then sort of expands on that and shows that the world is a bit more complicated. But it's an interesting thing because it does explain a lot of things. As with everything, all models are wrong, but some are useful. So it's probably a useful model. It doesn't mean that it's already always correct. But that's a great recommendation. I don't think I have any recommendations for me for now. I was traveling between the last episode and this one, so I was busy talking to people. Maybe the only recommendation is I was at CVPR. It was really good. I recommend going to conferences if you can do it, if your employer is willing to pay or something like that. There's a lot of really smart people that gather and a lot of really cool ideas. Some of the work that is being shown there is like, things that aren't in your space, but there's a lot of cross-pollination going on and a lot of people that are taking these works and being inspired to apply them in production. So for me, it was a great experience, and I recommend it if you can do it. We might be going to ICML, which I think is in a month from now in Vienna. So if you're looking for a conference to go to, that might be for you. So check it out. Michał, thank you so much for taking the time. And thank you everyone for joining.
Yeah, thanks for inviting me again.
See you next time. Bye.
Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.